Today's lesson is on the linear function that is in slope-intercept form, and that is the y equals mx plus b. It's called slope-intercept form because in the equation it tells you the slope and it tells you the y-intercept. So m in your equation is always your slope and b is always your y-intercept. However, the equation given to you might not always be in the proper form. So what you need to do is often rewrite it in the proper form by solving for y, and then after it's in the proper form you can find the slope and find the y-intercept. Our first example, let's start with one that just starts out in the correct form, y equals negative 5x minus 2. And all we're doing, very, very easy, your slope is the number attached with x, so it's negative 5, and the y-intercept is your last number, but make sure you take the sign in front of it, so our y-intercept is negative 2. Now here's a second equation, y minus 2x equals 3. This is not in the correct form, y equals mx plus b, because y is not by itself on one side of the equal sign, so we need to solve for y by adding 2x on both sides, which will give us y equals 3 plus 2x, but then to write it in the proper form, let's write our slope first, the number with x, so 2x plus 3, and then we state that our slope is 2 and our y-intercept is a positive 3. Rewrite it and then state your slope and y-intercept. Here's our third example, y plus 1/5 equals negative x. We want to solve for y, so let's subtract 1/5 on both sides. So y equals negative x minus 1/5. And that means that our slope is negative 1 and our y-intercept is a negative 1/5. Alright, saved the best one for last. We want to solve for y. This one is a little more complicated, but because we have a set of parentheses, we want to start with the distributive property. Let's distribute, which leaves us with 3y still left over on the left. 9 times 2 is 18, and 9 times 4 is 36, so minus 36x. And now to get y by itself, I need to divide by 3, which means divide all numbers by 3. So y equals 18 divided by 3 is 6, minus 36 divided by 3 is 12x. Still have to do one more step, and that's to rewrite it. The slope comes first, take the sign in front. The slope is a negative 12x, and then this 6 is positive, so plus 6 at the end. And that means my slope is negative 12, and my y-intercept is a positive 6. Now let's graph linear equations that are in slope-intercept form. Y equals 1/4 x minus 2. So this is in the proper form, so we can go ahead and first let's find our y-intercept. Our y-intercept is negative 2, so on the y-axis I need to find negative 2 and put a dot. And then my slope, and remember when we're graphing slope, we want to think rise over run. And we want to consider our slope as a fraction, which it already is, 1/4. So that means we're going to rise 1, run 4. And I always start, you always go either up or down, but always to the right to start. So go up 1, right 4. Up 1, right 4. If you start always going to the right, it will guarantee that you will get the line in the correct direction because it's a positive slope. So it's easy to mix up a positive versus negative slope. So now let's go backwards, and now we can go to the left, down 1, left 4. Down 1, left 4. And we have our lines so we can connect them all across the entire graph. And there we have graphed this equation, y equals 1/4 x minus 2. Here is our second equation, y equals 7 minus 3x. And it's not exactly in the right form because our slope needs to come first, so let's rewrite it. Y equals, take the sign in front, so it's negative 3x, and it's a positive 7, so plus 7. So my y-intercept is at a positive 7. So on the y-axis, let's put a point at positive 7. And then my slope is negative 3. Rise over run. To make negative 3 a fraction, we're going to write it over 1, negative 3 over 1. So starting at the y-intercept, we need to rise negative 3, run 1. So you always go up or down, and then always go to the right. So I'm going to go down 3, 1, 2, 3, and go right 1. Down 3, right 1. Continue that pattern all the way down and go backwards, up 3, left 1. And let's connect all those dots for a line. And just always double check. Before I move on to the next problem, I always do a double check. My slope is negative, and from left to right, am I going downhill? I am, therefore I know my line is in the correct direction. Now on this graph, I'm going to graph two lines, and these are my special cases. And this is y equals 2, and then I'm also going to graph the line x equals negative 5. So these are actually equations for lines, not just points. If you think about this, this is saying that there is no slope. It's like 0x plus 2. So whenever you have just y equals a number, let's see, we start at 2 because that's the y-intercept, and if the slope is 0, that means I have a horizontal line at y equals 2. And then maybe you can guess what we will do when you have x equals negative 5. That is going to be a vertical line where the slope is undefined. So we need to find negative 5 on the x-axis and then draw a vertical line through that point. So that's how you graph the special cases of horizontal and vertical lines. Last example of this lesson, we have just a small story problem. And we're going to, from the story problem, write our own equation and then draw the graph. It says a television production company charges a basic fee of $4,000 and then $2,000 per hour when filming a commercial. So think about this $2,000 per hour. That is your slope. So y equals 2,000x. And then the initial fee, no matter what, you have to pay this $4,000. So let's think about what our two variables are for this graph. We have money, and then we have this per hour. So for the x-axis, that is almost always time, we have hours, and then y, we have money. Now we need to label this. We have to think, well, we're starting at 4,000 and increasing by 2,000 each time. So why don't we count by 2's, but know that it's going to be in thousands. 2,000, 4,000. I'm going to skip a line for 6,000, 8, 10, 12, 14, 16, 18, 20. So 20,000. And then hours, we can just count by ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright, so let's think about how we will graph this. We start at 4,000, and we're increasing by $2,000, $2,000 per 1 hour. So we're going to go up $2,000 over 1 hour. Up $2,000 over 1 hour. So the slope looks like 1 over 1 when it's actually 2,000 over 1. Get all your points and then graph the line. And there you go. There's the full lesson on slope-intercept form of a linear function. Later this unit, you're going to learn 2 other forms of linear equations. Good luck.